Hey, hello everyone. We'll give 5 or 10 minutes to get all people joined together. My name is Alberto, by the way, Alberto. You can pronounce it as Albert if you want, no problem. I'm from Mexico, and this is the second part of our processing images in Matlab workshop. So we'll start in some minutes. I'm going to go in backstage for now, but feel free to comment. Hello, I see one person already connect. I'm here. We're going to start in some minutes the workshop to let more people to join us. But tell me, where are you from? What do you do? Where are you studying? Where do you work? So let's make some chit chat before the workshop starts. I'm going to change the brand. Mm, hello, hello. Can you hear me well? I would love to see in the comment section all your answers. Hey, we're just making time to see if more people can join us. But hello to everyone who is already here. Again, my name is Alberto. I'm from Mexico, and please leave on the comments where are you from. Oh, hey, Nugi, I see you came back for the second part. That's awesome. I hope you enjoyed it as the first time. Canada and India, that's cool. What time is it on your time zone right now? For me, it's 12 a.m. No, sorry, p.m. Yeah, 12 p.m. So it's this is going to be my first thing in the day. um, 5 more minutes and we can start. So it's very late for you. Okay, that's cool. I'm glad you joined me. Um, so I know that Nogi from the last workshop we had. You're like 1 to 10 in MATLAB, but what about the other you guys? Are you familiar with MATLAB language, with data processing and image recognition? What about those topics? What do you expect from the workshop? That it's an interesting question. Boom, boom, boom. Um, I'm just making sure everything's okay. A review from all I learned, sorry, from the last workshop that I should run Matlab in online version to get everyone at the same environment as me. Okay. Yeah, I hope it too. So, here, let me show. I hope MATLAB works faster today. It could be due to a lot of facts. It could be my internet connection and the fact that I'm running simultaneously the compiler and the stream and a lot of windows on my Mac. But uh, let's give MATLAB another shot. I see two more people join us. Hey, hello. And we were talking about like where are we? I mean, I'm from Mexico. We have people from Canada and India, and we were talking about what you expect from the workshop. What do you want to learn? What do you think we will learn here? I don't know if you join us the last time, but we see color segmentation. We see different types of color. Um, yeah, of course, segmentations like RGB, like HSB, like CYM. And today we want to use that to learn how to make our own histogram tool. If you're kind of familiar with photograph and other image editing tools like Photoshop and that thing, you'll have to see that the histogram tells you like the the colors that you have in your picture. For example, if we take a photo frame from this image of me, we will see like there's a lot of blue because my shirt, maybe the wall it's kind of gray, but I see it with a green tone, and my face is it's really red. So we will see like the the blue bar going on the top and the red like in the middle and some little of green on there. But let's see what we're talking about, right? Hey Jacqueline, I see you here. That's cool. So 1 minute and we can start, right? um, Hi Jacqueline, how are you doing? I'm very excited to giving this workshop. User not found. Hello, how are you? Um, I don't know if you guys have access from your schools to the MATLAB tool. Um, Probably most schools have these like educational license that can use MATLAB online or create a MathWorks account. You can do it if you want in this moment, or try to do it and verify if your school gives that. But if don't worry. Feel free to follow us on this workshop. And I mean, again, MATLAB is just a tool. You can do this in Python, JavaScript, even, or any other language that you prefer, that you want, that you master. I'm going to use this in. I'm going to give this workshop in MATLAB because I think it has very cool built-in features that can help us develop quickly. But I'm sure there are a lot of Python packages or libraries or whatever can help you. For sure, Matlab and NumPy helps you do this as the same as MATLAB because they are like pretty similar. Um, and okay, we can start now. I'm going to share my screen. I hope everybody, can see this. If don't, please leave it in the comments. And I'm going to take from here. Let's do a little recap of what we see the last time. The first thing is we're using a type of Matlab file called live script, which is different from the old scripts because we can easily run sections of code. Like if you're familiar with the Python environment, this is like a collab document, right? The other thing we saw in the last section, it's color segmentation. And in this case, for example, I'm going to show you a pictures from me in Ensenada. Jacqueline, if you're here, you take this picture. And we read this using imread function, and we show with imshow function the image stored in the imread response, right? Imread by default lead us to an RGB color segmentation image, so we can easily split this image in the first layer, and we get the red layer. The second layer give us the green layer, and the third layer give us the blue layer. So if you see the original picture, where you will see that the red letters, which are E and A, are the lightest in the red layer, and well, the yellow, because yellow are compound using red. It's also very light gray. And the green E, which is here, it's very light, the green layer. And for the last layer, the E that it's here, it's the lightest on the blue layer. You see it, right? Again, we can transform this into an CYM color segment, just transforming the matrix. And we will do that by moving the point um, of the matrix we're step on, adding 255 values to the layer of every point we are talking about, right? So 255 minus the every single value which is on the first layer of the right, no, sorry, um, red values led us to the cyan layer, which is here. Cyan, it's 255 minus every single value of the red layer. And for the yellow layer, it's the same, but we subtract the last layer, which is the third one. We call it the blue layer, right? And the magenta, I was forgetting about that. It's again 255 minus the second layer, which is the green layer. And that gives us the color segmentation. We talk about that RGB color system is frequently used to manipulate non-real photos, but computer generated photos, like a drawing, I don't know, something you made in Blender or something. Yeah, not real life photos. Um, CYM color segmentation system, it's used to print like computer generated things, but to print it in real life, because it's easy to get this ink addition. We were talking about, like, if you want to print white in RGB color system, you will have to add all values of the three layers: full layer of red, a full layer of blue, and full layer of green. That gives us white. And mostly The white it's pretty common to see in the pictures we want to print. So that's a big amount of ink we are spending on every single paper. So CYM that has the advantage that if we want to print white, it's it's equal to not putting any kind of ink on the layer. So it's zero of cyan, zero of magenta, and zero of yellow. Um, and the last one is the HSB, which Matlab comes with a built-in function called RGB to HSB. That's why I'm using Matlab, because again, it has pretty useful built-in functions. HSB gives us the HSB matrix. Sorry, RGB to HSB give us the HSB matrix, just passing as an argument the matrix that storage the data of our image, and we split this full matrix to get individually the H layer, the S layer, and the B layer, right? The first one is the H, the second the S, and the last one is the B. H stands for hue, which means that in this layer we have every single value of the hue we want in the cone. Um, S is the saturation, which means we have here the information about what's well, um, what parts of the image has enough saturation and which don't. The black parts are the ones that have good color saturation, and the white parts are the ones that have no good color saturation. And the last thing, it's the value. Value, you can imagine this like, hey, you're just showing us a gray image with no color, but this tells us like which parts of the images have the black and the white parts, because on the hue, um, this part don't tell us the white and the black parts, because it's not possible. If again, if we search the cone hue, sorry, the cone HSB, we will see that around the cone, which is the value of the hue, there is no either white or black. There are in the middle that values. So if we want to see in an image what parts are white or black, that's the information the value layer give us, right? Again, this color system, it's the one that it's most commonly used for image processing in for real life pictures, similar of what are we doing here, which there are images of me, one in Ensenada and the other just a selfie I took when I was making this document. Yeah, that's a little recap of what we do last time, but let's jump in. What are we going to do today? Um, we are going to do this, which is the histogram. Let me see if you have any comments at this point. Oh yeah, oh my God, I did. Hello, hello, Ghost Recorder. That's cool. So good MATLAB practices again. CLC to clean the command window, clear all to clear our workspace, which is the space in which we storage our variables, values, and names, and close all. This command closes our prompted windows in the code. And first thing first, we want to storage an image with im. I'm just copying and pasting this with the imread command. This is not going to work because I don't have this anymore here. But let's do PWD. Oh, tell me if you have any image in mind that you would like to see the real colors of that. But I have one in mind. I don't know if any of your countries this was a thing like it was in mine, but here in Mexico, a few years ago, we had like a massive social media fight because one picture of a dress, some people see it like gold and white, and some other people saw it like green and black, and that it's a very big difference in colors, right? Um, well, let's get science tell us what are the real colors of that image. Um, that photo is this. Let me search for that. Um, okay, you see here the comparison, but the real picture is this. I don't know, people, what color you see this. Please leave it on the comments. But I swear for my mother, I see this white and gold. I yeah, I know. If you see it other color, tell me. But I see it white and gold. I know it might be another color. Again, I see it white and gold. Let's find out what are the real colors of this image. I'm going to download this. Let's see what are your sponsors. I see it white and gold. Okay, that's cool. You saw it white and gold, same as me. And just this is how you comment things in Matlab. Again, percentage sign. Just want to know where I'm step. I'm step on Matlab drive. Be that right. So just a second. I'm going to pass the image I download to this carpet folder. Sorry. Okay. It seems that we have it now. So we can uncomment this and let's do vestido.jpg and let's run this section of code. Okay, here's our picture, right? And I I know that Nugi see it the same color as I do, which is white and gold. But let's see if that's the real answer. How are we going to do that? Well, to create the histogram, we're going to use the function zeros. What does zeros do? Zeros create an array, well, a matrix, depend on the values we passed it. But in this, for this example, we were going to create a matrix that has values, um, which is a metric of zeros, basically. That's why it's called zeros. So we will going to copy this. Wait, sorry, we will going to copy this and paste it here again. So I'm going to delete the semicolon so you can see the value is stored in his red, his green, and his blue. What is that? This is what we're going to use to plot or lines that give us the values, right? Um, the values stored here are, oh, oh, it's still processing. Remember, MATLAB, it's a little bit slowly, so that's why. Let me see. Okay, we're still good. We're still good. Once this is done, you will see here in the workspace the his green and the his blue names, and um, we can inspect which values are stored in there. Again, it will be just zeros. That's what zeros do. If you got any question using MATLAB commands, you can always come to the command window and type help and the command. So help zeros, and we get the answer at some point. Yeah, give some time to MATLAB. He needs to think about his life's decisions. Just to going to take some water. Oh my god. Hmm. Weird. This is taking a lot of time. It's a very simple command. I don't know why. Mm, it will be my internet connection. Can you, everybody, people, hear me well? I don't know. I hope it's not my internet connection. I just need an answer for you. I'm going to close this and this. Right. Um, come on, MATLAB. Um, I'm going to stop it. Again, help zeros. Okay. Uh, Zeros tell us like it gives an n by n matrix of zeros if we just give one argument, but in this case we are giving two, 1 and 256. um, why is that? Remember, MATLAB is not a zero index language. I'm going to send language between quotes. I don't think MATLAB is a language, but yeah, um, it's a not zero index language. It means like when we start counting, it starts with one, not with zero, as our real languages. Like again, I'm going to use a lot of Python references. But yes, for example, you as developers know that when we want to do something with code, uh, we usually start with zero, but MATLAB no. MATLAB starts with one. That's why we're giving 1 to 256 because we want 0 and 255 real values. So that means we generate an 1 to 256 matrix array. Um, and let's run this code. Let's see if it run it quicker this time. I'm going to assume that's because of all the data that has to um, display here, and so I'm going to put the semicolons again and run this. Come on. Come on. Okay. Yeah, I know what is not working. I forgot. You see this command right here, right? Imcrop. That's another thing we haven't seen. I'm going to just comment this. So and comment this again. And the im show we're going to see it's here ima, and again delete the semicolons. Okay, sorry, that was my fault. And we can do this again. Sure. So we have the matrix 1 by 255 values. And a matrix 1 by 255 value, technically it's just a vector because it's just one row. But if you combine these these three, his red, his green, and his blue layers in just one matrix, that's why I'm calling this the whole matrix, right? Um, what is happening with the imcrop function? Let's let's find out. So help imcrop, right? Um, what imcrop does, it's like you can uh, select a specific part of the image you're displaying. I passed the ima from vestido, uh, which is the word for dress. Sorry, in Spanish, vestido means dress. The thing right here. Um, we pass the image of vestido, and we cut a little section to just analyze the information in that section we choose. So and we store the cropped section in an S value, and we show that S value, right? Let's do that. Let's uncomment this, and let's comment this, and let's run the whole program. So in this point, you will see that this is like waiting, right? It probably will be the same value, Matlab says, but I don't know. I need to run these lines. But to do so, I will need you to select the part of the image that you want to crop. So I'm going to select this part, right? And I'm going to click enter, and we will see the cropped section here. That's what are we showing in imshow as stores the crop image from ima, and then the program can run. We are not seeing the output of this because I put the semicolons, and that was the explanation of what was happening. Sorry, my bad. That happened because of copy pasting this. So the next thing we have now our east, red, blue vectors, but we need some more information about S, which is which size is, because you can see I can run this again and select a very other part of the dress. This time I do it more like in a vertical way, portrait way. So it's different, right? That's why every time we run this code, we will need to get the data from rows and columns. From size, common, and passing S matrix. So let's show. I'm remove the semicolons, so we will see the values here. And for let's make a for loop. E j, sorry, from 0 to every rows. and a nested for loop from E from 1 to every columns. And end. At this moment, just we want to see how many rows and how many columns we have. I'm going to select a different part of the dress. We have 45 rows and 213 columns. I'm going to see if you have any questions at this point. Okay, no more comments. That's cool. Yeah, what are we going to do with this information? Well, we need to um, add this information to our hist vectors, right? We have a formula for that, so let's copy paste that. I'm going to explain what is happening here. Oh, wait. So you will see that in his red, his green, and his blue, first we are accessing the first row and the part, and the part of S, which is, I put here Y and X. Let's see why I call it that way. So instead of J and I use Y and X. That makes sense because we are talking about like the points if you want to see in a system which it's always like the horizontal line and y the vertical line, but let's yeah, why not, let's call it that way. um, yeah, let's call it that way. So we access the y and x indexes of s value, which is the crop image, and we give it that information to access the hist value of that plus one. Y plus one, remember again, MATLAB, it's not a zero index language, so we need to add one value to that to make sure we're pointing to the right position. Instead of that, we will be pointing always a point after that. Sorry, before that. And what are we going to do? We're going to reassign the value of his red to his red, but uh, plus one. What does that mean? There are other ways to do this more easily in MATLAB because of the sure syntax, but I think this is the best option so we can get it clear, right? Um, we're running a program which takes every pixel of the image, but not the original image. Remember, we're getting information about the cropped image. So his red and his green and his blue are vectors compound of zero values, and we need to store the image of the first layer, which is the red layer for the red histogram vector, the second layer, which is the green layer from the green histogram vector, and the third layer, which is the blue vector of the histogram, right? Uh, and once we get that information, we just can add it or store the value in the previous value. So what does that mean? That means that When we plot this, we're going to see all the values stored in a graphic way, which means it's a line, and it depends on the values we found in the cropped image, what position this line will have. For example, in this, we can see there's a lot of white, right? So that means, remember, for RGB color systems, white it's made if we had a lot of red, a lot of green, a lot of blue. Pure white, it's made of 255 values of red, 255 values of green, and 255 values of blue. Um, so a pure white will be this line, this red line, almost hitting the 255 values to the right, and almost the green hitting the 255 values to the right again, and the blue same as blue. If we have a compound image like this with white and gold, we will not see that. We will see uh, gold, it's like yellow, but with more less light, less saturated color. So will be like a lot of blue because we have the white again. Remember that, but red and green. Like in the middle of the histogram. So histogram will show us from 0 to 155 values in the X section, um, and 255 values in the Y. Uh, we can do that. We can show, so we can plot, which is the command for showing values of a vector in a yeah, in a plot line. You can see this 2D line plot. We can do graph, which show that in 3D, but that makes no sense, right? Because we have just values for y and x. And we can plot hist ref. Oh, sorry, hist ref. And let's see what does that do. Remember, we are going to show, we are going to pick a section which it's pure white, like this. And oh, this is a problem. Index into position exceeds array bounds. Index must not exceed. Why is that? Index in position 2, which means, okay. Index in position 2. 75. I don't know what's that. If we have 255. Uh, his red, y x, his red s. Okay, let's make that adjustment and select again. Yeah. Oh, so what happened there? Remember, we can always verify what does the MATLAB commands do here. So we're going to make size. So size return the values for a m by n matrix containing the number of rows, columns, etc. But S does not have um, rows and columns. It has also layers. You can call it like a three-dimensional matrix, because we have 45 by 78 values, but in every single layer, which has the first layer for red, second layer for green, and third layer for blue. Remember that. And so when we want to store that information in here, we were forgetting that we want the layer information of that separately. That means here we were storing the three-layer information for every single row. So that's why. Uh, but with that, we have this. Remember that, and we see something which is kind of interesting because remember we said when we have a pure uh, white image, we was expecting to see this line right here, hitting the 255 values. So that means two things. Our program is wrong. We make things not the right way, or maybe, and I'm just saying maybe, the image it's not white. Let's try with another image. You want? We can search for an image. We're sure it's white. We can just Google white floor or white door, white floor. Why not? Yes, this can work. I'm going to download this. Give me a minute. Oh, my internet it's okay. And import it to the file we are going to use. It's already here. I have it here, so we can do flower. And let's do another thing. Here it's kind of weird that the his red line it's blue, so we will use this to make it red and run the program again. And we are going to select a white part. I think this is pretty white. And yeah, this is what we were expecting. The red line hitting the 255 value. So this means this is really white. And as you can see, we can barely distinguish the white from the image cropped and the white from the Matlab environment. That's funny. That means it's almost a pure white. But if we can change the background from the Matlab IDE, we could see a white square here, right? I'm just going to semicolon this. And let's add the other lines for the histogram red and the histogram, sorry, the histogram green and the histogram blue. To do this in the same plot, we use the command hold and on, and we plot the hist green, but let's do it with a green color, and let's plot the hist blue, and let's do it with a blue color. Oh, blue color, and just we hold off. And we can run this again. Let's see if we choose again a very white part of here. We see there are overlaid, right? In this little point right here, we see the red value. In this little point right here, we see the green value. At the front of all, we see the blue value. That means we're going good. We choose good our program. We code it the right way, and again we can prove that selecting another part of the image. Here I see this is like almost black. So again our values are zero because there's no color at all. But let's run again and select another part that give us more information. For example, here, let's select this little green rectangle. And as you can see, the green line, it's in the middle because it's not that green. It's a very light green, but our histogram detects also a little bit of blue and a little, well, not a little, a lot of red. But yeah, with this we approve our program. It's right. Let's return to the vestido image, and let's see what's happening. So again, one just one histogram line tells us not that of much information, but with three lines we can know what's happening with more detail. So if we select this here, and we thought it's a white dress, this tells us uh, we can search again for the image, and according to some people, the dress is not white and gold as I saw it. It's blue and black. We choose here a part we thought it was white, but according to some people, that part it's blue. Here we see the blue line more mm, with more value. So these people, not me, these people, it's scientifically right, right? Uh, Here is the proof that the dress is blue, but it's gold or it's black. Let's find out. See, if we run the code and we choose the gold part, or what I see as gold, we can see that the colors are slightly to the left of the values. It's not pure because there are not zero value, but this is not gold. This is not the color of gold. So yes, it may be black. But in our defense, for the all the people that see this dressed white and gold, it's not a pure black and not a pure blue. If we run this again and we choose a white part of the dress, we can see it's, yeah, it's blue, but the red and the green lines are not zero. There are a lot of influence of that values here. So yeah, it is blue, but it's not a perfect blue. But to be honest, it's kind of difficult to find that in the histograms. And also remember, RGB color system affects or get affected, sorry, a lot by the environmental things in the picture. So if we see the original image here, we will see that there's a lot of light coming from this part. So in the light conditions where this picture were taken, um, there's a lot of noise about that. So that's why a lot of people like me see the image white and gold, because of the light environment here. If we search for this dress, see, here I see it white, sorry, black and blue. I see the original colors because this light environment it's less affected by the sun, for example, or by any other source of light here. It's probably a studio photo of the model with the dress. So here at the outside, with a lot of light coming from the sun or etc., we can see this dress is apparently white and gold, but it's not. It's blue and black. So that's resolved the polemic issue in with the dress. I mean, you can change what I'm really seeing here. I swear again, for God, this is white and gold, or at least I see it that way. But science tells us not. Science tells us this dress it's blue, and this dress is black. So it's blue and black. So yeah, that's how we did a histogram example. I see you don't have any other comments here, so we're going to pass to the next section, which is border detection. Um, Before going that, histogram can be useful for more things that just proving people that were wrong about an image in Facebook, but it can be useful if you do like data or image processing to recognize with a program what colors are in an image. I mean, a system can analyze these values and, according to that, knows like, hey, your white, your T is white, your T is blue, your color of hair is red, your I don't know. The sign on the street is red. That should mean I should stop. Or the color of the traffic light it's blue. That means I can go on. Uh, that color things you can make with the histogram tool we just learned. And I don't know you guys, but I think that's pretty cool. Um, yeah, if you want to take a screenshot of this, that's okay. I mean, you can always see this again in wherever you want on the Twitch recordings. But let's delete this and let's return to the flower picture. Oh, yeah. I was thinking like, why does the flower didn't show up? But we didn't show it. Here it is. So, what are we going to do now? This little flower has a really beautiful shape. Uh, I'm just following the shape here with the mouse. And there is a way, actually, there are three ways. There are more, but I'm going to show you three ways in which we can use image processing to get the shape of this flower. Not just the shape of the flower, but all the shapes, all the lines, or the borders in the picture, right? So I have the code here. The code, it's called gradient border detection. And if you don't know what is a gradient, it's the rate of change of a system, but it's a vector that just that tell us the direction in which the rate of change is going. For example, gradient, it's also useful to know where you want to know the body of a mesh, uh, or the top. I mean, where you are in the top. And there's a lot of useful things we can do with gradient, but let's not get yeah, let's not focus on the maths here. uh, we you are going just to use the grading as a tool to get the image borders. And to start, let's do something that it's to pass the RGB. Oh, sorry. Yeah, I was just seeing that you didn't have any comment on that. Um, yeah, let's do something. Let's pass our values to RGB to a grayscale. Um, what's that? Because it's easy to us here just to not focus on the colors, but the grayscale give us a lot of information about the shape of the image, right? Which is kind of similar of what we do in, for example, HSV color segmentation with the saturation layer. Um, to do that, also MATLAB comes with a pretty good built-in function called RGB to gray, which it's like this function where um, IMA gray, which is RGB to gray, and we have to pass IMA here. Let's see what IMA gray value is. And we see that we have unit 8, unit 8 metrics of these 810 values, but we want something that it's not unit 8, a unit 8 matrix. Why is that? Let me show you what we stored here. Okay. Oh, oh yeah. Here we see the values in the first layer, right? And here it seems like we don't have any other layer. But what happened? Again, we can just help and RGB to gray, and let's uh, wait for MATLAB. Okay, here it is. Converts the true color image RGB to a grayscale intensity image. Returns a grayscale color map equivalent to the argument that we passed. This equivalent means that it's not the actual value of the original one. So that's an issue because we lose information, and we don't want to lose information. We see how it's done here. For example, to get the grayscale, MATLAB does multiply the red layer times this value, and it This is like we sum the green layer times this value, etc. Right? But there's a way we can reduce the information we lose. We can easily double this one here, and we run this, and we get the information here. And here we don't have the oh, okay, sorry, let me scroll. Here we don't have the uint 8 base array, which we had previously on. Um, yeah, that's the thing. So next, we can. Oh, yeah, I was forgetting. Oh, lovely. Thanks. The next thing we can do, it's just semicolon this and this, so you won't see a lot of raw numbers, and we can show the grayscale image. Oh, and again, as previously we do with the histogram code, we can do. We need to get information about the size of the ImGray image, which is the rows, the columns. And in this case, if you remember the matrix, we don't need the layers because there's only one layer. So ImGray size, ImGray, and we will do two nested loops. The J starting with 0, 2 rows, and the I starting with a 1. Sorry, I said 0 here, but it's 1, 2 columns. And we hit end, and we hit end. Oh, so my bad, end. And then we can show what are we going to do here. That we are going to. This is kind of hard to explain because of the math, but let me let me get you with something. For example, oh, I'm just going to copy this. And that's the same basically, but there's a little difference here. Here we start with 2, right? That's let's see why. If we start, we are going to use G goes for gradient, right? And X it's just the X vector, and Y it's not sorry, not the vector. It's the gradient X matrix, and we need again an gradient Y matrix and a global gradient matrix, and I'm going to explain why. The first time we run the code, we will be step if we leave here this in the first value of the of the gradient matrix, but we will need to do something that we need to return one value and return one value in y and in x. Why is that? Remember, gradient tell us the rate of change and the direction that are we going, right? So the function we're using it's to the ImGray image, the original data. We need to get in every value of the rows uh, plus, and we will be recording the next value of the columns, and we will subtract uh, in grade the previously value of that in X. So again, remember we're on the X gradient. For the X gradient, the value of the first, yeah, the first value, which will be the first here, because we're starting the Y iteration in two. These are rows in English, and these are columns in English. So we start analyzing the image. And remember, this goes pixel by pixel. So the first pixel of the columns and the first and the second pixel of the rows. No, sorry, the other way. The first pixel of the rows and the second pixel of the columns needs to get subtracted from the first pixel of the rows, but the previous pixel of the columns. That means, again, the rate of change, um, but pointing the direction. And that just we divided the value in two. And it's almost the same thing from the y matrix from the gradient, but instead of giving it to the columns, which are the x values, we're doing that to the rows, which is the y values. And we need to change this here, and the anyway, anyway. And we need to do that with the values from the rows. So again, I'm trying to explain this the easiest way I can. If something doesn't get clear enough, please ask me. Um, but imagine we're going to get pixel by pixel, but in this pixel iteration, we need to subtract the value from the previously pixel to the next pixel we are, right? And with that, divided by two, we get the information that we want in the matrix of x's. Um, and the same goes for the columns. Sorry, for the rows. We're going to go pixel by pixel, subtracting the value of the previously row to the next row we are step on, and we give that value to the point of gradient in y, of the gradient in x, which is the columns gradient and the rows gradient. And for the last, we need to regroup those matrices. And to do that, it's just like a single. We elevate the values here, and we use squared. It's easy if you think about it, like x. Uh, oh, I forgot how to display that. I just copy and paste. If we elevate this to 2 plus, uh, okay, yeah, it's a plus b elevated as 2, it's equal to c elevated plus 2, right? So if we want to get rid of this, we're just going to copy, use the squared of this, and that means this is C, right? Because C elevated to 2 squared, it's just C, and this is what are we doing here? But with every single value to the matrix. This point, this dot right here means that this operation will be performed to every single value of the matrix of the gx matrix, which is the gradient for x, and the same from the gradient for y. We're going to elevate every single value from that matrix and just add it to the together, and then we're going to square that value and store it in the full matrix. Uh, and now we can graphically see what we were talking about. This is not an image at this point, but we will become an image. Uh, this is a handy tool, and I want to see it first, which it's called Mesh. Mesh then shows an image, but it shows every single value in a mesh graph. And let's start with GX, right? Oh, first I'm going to see if you have any question. Tried to do this once in Matlab, and man, I have almost broken my head. Okay, so I hope this helps you to do that. And if you have any specific question, you can feel free to ask. I mean, I don't know if I can answer your question, but I'll give a try. I just want to make sure it's my best effort to help you get along with that. MATLAB isn't that difficult, and data image processing isn't that difficult either. We just need to help to do like a little background concepts for everything. In this case, I don't know if I'm doing the right thing, just saying like, hey, forget about the math with the gradient, just let's apply this formula. But if you want it, at some point we can go further with the maths of the gradient. In this point, just trust me, this is what a gradient do. And it's an easy formula you can use. Um, Probably, and now that I think of it, MATLAB will have another gradient function, just the same as we don't you do the matrix transformation here. We just say, hey, MATLAB, do this matrix transformation for me using RGB to gray function. Um, but if we do that, we will have a probably 10 10 rows program, so that's not as amazing as doing this. I'm kidding. I'm doing this because I think it's important to uh, think like if we're not doing the entire matter of metrics of gradients, sorry, at least we can see like with a little x-ray what is going on. Oh yes, I need to run the program to show you how the mesh of the columns grading it's displayed. Uh, let's hope digo, sorry, MATLAB Online can handle this comment. Come on, it's supposed to be this one, but I think it's not working that well. Come on, you can do it, MATLAB. Let's see if you have any other question. Oh, the comment I was talking about is this. Thanks, Alex, for the comment. Again, if any of you guys have any question on this point, please leave it on the comment section, and I will try to answer it. So it seems like MATLAB is not. Oh, okay. Firefox wants to open a new window. That maybe it's what happened. I'm just going to allow it. What? This application must be launched from Matlab. Okay, okay. I'm just going to run it again. Let's see what happened. Come on, come on. Uh, Little break for water. Cool. I don't know what happened with that opening another window thing, but here it is. Let's see if we can manipulate this. I'm going to delete this, and I'm going to delete the no. So yeah, I'm going to delete this. Um, Come on, I'm going to run this again. So that's not that of computational power we will need. You can do this, Matlab. Don't let me be a joke. To be honest, I don't like that much of MATLAB because of things like this. Uh, yeah, that's the really hard truth, but it's an easy way to get started with things like that. We wanted to do this in other languages. We probably can do a matrix transformation like this. We will need to apply formula just as we are doing with the gradient, or go with further code things. But I think Mesh is not going to work on this online environment, so that's a shame. It's a really nice tool to visualize what data looks like, but okay, maybe it's working now. No, no, I don't. So let's show DGX gradient, but first let's uint 8 that, because that's what imshow function expect uint 8 value metrics. And let's run this and hope MATLAB can handle this. Come on. Oh yeah, here it is. You can see there are slightly like white lines over here. I'm trying to follow that with the cursor, but that means we're doing great. We just need something else. We are going to multiply this by a factor of 1.5 to escalate the mask we are running, and let's see what happened now. Come on, MATLAB. Okay, maybe it was too much. Let's see what I do here. What value? Oh, fuck. It was not zero point 0.5, it was 5. And again, the dot means for every single value here, we are going to multiply it, not just the global value of the matrix. Just we will go value by value multiplying this. So for example, MATLAB here is showing us the matrix values. So, for example, the first one, 29.5, will be multiplied by 5, and we will have the result stored in the same location. Uh, let's run that. And what we have is this, the result. That's cool, right? We can see the little shapes here, but um, there's a thing. There's a thing that annoys me. If we show the original image, im show here, the original image, will oh, ima show, im show, sorry, we will see that we're missing some parts of the lines of the borders. Uh, Come on, we have like this, this, and this, like yeah, like if we have a light over here and just the things the sun is brightening for us, but this part seems like no borders at all. And that's a reason of that. Remember, we're showing just the x gradient, and x stands for columns. And if we see the gradient, we just have the information on the x line, which is the horizontal one. Let's plot the in show doing 8 y dot times 5 image to see what happened here. Uh, what do you expect to see? In the previously one, we saw the lines on the X, and yes, in this one, we saw the lines on the rows. So we probably need a combination of both. That's what we do with the global or the G gradient metrics. So let's just show that. I think here it's as we do a squared value here, it's not necessarily to do unit 8 performance here. We just can show the g dot times 5 value. Um, we can run this, and we hope to see now the entire picture with all the borders. Okay, okay, that's weird. But yes, maybe here 5 it's a lot of a lot of pressure for that. So let's just not pressure. What I'm trying to say it's a bigger scale. Maybe we don't need that. Maybe just with the values of G, we are good. So let's run that. And if we don't get enough focus, we can multiply by 2 or by zero point 0.5 or something like that. Or yeah, maybe we can, instead of multiplying by 5, we can multiply by dot 5 as we was doing in the other part. But you can see we have a good resolution with all the lines in the picture, even with these little lines here, we have them, and I think it's really cool. But maybe we just want like the borders of the flower, so we can do solution. Oh, my battery is running. So with this, we can end up the transmission. Let's just wait to see the image. Yes, we have like a more or yeah, a more clean picture. We can multiply by 2 maybe to see what happened. And I hope you're getting as much excitement as I am getting because we have this right. Okay, yeah, look what a beautiful picture. Maybe 0.1 will show us less details with the lines. Come on, Matlab, you can do this. Come on. Oh, yeah, this is what I was hoping to get. This is a beautiful picture of all the borders of the original one. Look how we have these details of the leaf. Yeah, I think it's a leaf. Yeah, and just the shape of the flower and this root here. I don't know what it is, but it's awesome. I'm really happy with the result we get. Uh, see it, see it, see it, see it. It's really cool. I don't know if you guys enjoy it just as me. Uh, yeah, that's cool. The invert pencil. Um, you can always treat it like that, like, hey, I hand draw it this, or you can take it as a template for your next drawing if you do want to draw it with a pencil in the real world. Um, to get it to work, it will probably require much smaller image. Just a drop of. Okay, that's cool. That's cool. That's cool. Thanks for the advice, Jackson. Um, so you guys, I hope you enjoyed this MATLAB data image processing thing. I would love to do this again in further occasions. I think we still have a lot of things to cover. Again, my time flew. Oh, nice. But in further occasions, we can do this with Laplace transformation or with Prewitt mask or with Sovia masks. There are a lot of ways to we can do this. Um, Also, we can do more excitement things. We can do like stereoscopical vision to see with the distance in images, which I recently learned how to do that, and I think it's dope. But yeah, please leave it in the comments if you want to learn more about how to process images with computer science things. Also, if you don't want to do it in MATLAB, please tell me, and I can try to do it in the other language you want. Um, yeah, and that will be all. Again, thanks a lot of you guys for being here, and I'm going to end the transmission. Uh, yeah, that's accurate. This is what happened behind scenes when Photoshop do this for you. Probably a lot of Photoshop developers know perfectly, and yeah, more, they should know how these things works because they program it, right? Um, so if you want to do your own Photoshop tool, or you want to contribute to an open source project of photography or image edition or whatever things like that, you can easily do it now as you get more and more of these concepts. Um, but yes, and that's all. Thank you, you guys. I love you. So see you again soon. Bye.